Okay, my name is Brian Such. I am the Executive Vice President for Marubeni Citizen, and we bring in the Citizen-Cincom and Citizen-Miano products. And we have an exciting technology, LFV technology. It's a way to always break your chips, a consistent way. And if you review some things here, I ask a question. Do you run any materials like Inconel, Hastelloy, any stainless steels, even 17.4, 316, 304, copper, aluminum, all different kinds of plastics. And plastic seems easy, but plastics can be trouble to make chips. If you look on the right, if there's such a thing as a normal chip, and if you look on the left, just a consistent way of breaking chips that we call LFV technology. So as we look at this interesting technology, LFV, low frequency vibration cutting, got to look a little bit at the definition. What is it? The cutting method to oscillate the slide's axis, fully synchronized relative to spindle rotation to break chips. So in a way, it's really as simple as it's a chip breaking technology. And what better way to show this than real world examples is I have a couple examples of different materials. In this case, this is aluminum running, and we ran the part with and without LFV. And so on the left you have without, and on the right you have with. And as we look, you can instantly see the chip management, the ability to get chips in a way that the process is going to be unattended. Aluminum will have good tool life, but with all these chips, even just the ability to pick up the part with the subspindle can be a big problem. Sometimes if tools are indexing from tool to tool and there's a small diameter drill, we can break tooling just by this clump of bird's nest, these chips. And so LFV, this simple chip breaking technology, is going to help us make a stable process and be able to simply break chips. And once we get chip management, then we get part management. Here's an example of grooving. Also, grooving makes a circular chip that almost always wraps around the part. So cutting off or grooving. And with LFV, just program the same way, just add a G code, and now we are breaking chips. We can actually change the form of the chip. We can make them longer or shorter. It's all programmable. Now, if we look at another part, maybe a lot of people wouldn't think, well, plastics, anybody can run plastics. Plastics are very difficult. There's a lot of melting, and it's hard to get a good chip. And so you'll see very common situation here on the left side that we're taking a very heavy cut, and there's many parts like this where the left side is unmanageable. It's just not possible. Here on the right side with LFV, we have a perfectly controlled chip. Very interesting technology, LFV technology, chip breaking by oscillating the axis, perfectly synchronized with the spindle. And before we continue, I want to review that this LFV technology doesn't only work in a Z-axis like the upper picture left, but also works in the X-axis for grooving facing. But we can also use LFV for taper turning, a long taper, or even just a chamfer. It will actually oscillate at an angle with two axes. And we can actually use it with radius, G2, G3, with cutter comp. And basically, it follows the radius. Of course, we can use it for drilling. It's fantastic with drilling when you're down inside. It breaks fine chips. And a newer version of LFV is with threading. But before we get much more into it, I think it's good to understand how does Now let's take a look of the mechanics of LFV, and let's look deeper into the process of the cut. So as this animation is reflecting, here it's showing the tool moving, and on a Swiss machine the bar stock moves, but the process is the same. But you'll notice that the motion is tied in with the rotation of the spindle, we call phasing. And so as we're cutting and the material is rotating, it's in a perfect timing with the oscillation. And if we break this down and look at it in 360 degrees or one rotation, we can do in our industry, when we do milling and things, we call it unwrapping. So if we unwrap this one rotation cut, this chart is going to show it for us, and we're going to represent 360 degrees and then the distance of movement of the oscillation. And as this cut goes, it actually makes an irregular face or a corrugated cut. And on the second time around, the second cut, we will be producing an air cut. Now we can do as many oscillations as we want, but in this example, you'll see there's an air cut. And as this just keeps going around, we're producing perfect timing air cuts. So when that tool comes back in, it doesn't hit a flat wall of the turned surface. It's hitting a corrugated surface that is a different cutting pressure. And so as that continues down the part, when you finally stop, then it'll spin, normally, and we will make a true wall or a flat surface, removing that corrugation. It all happens automatically just with LFV. We just turn it on and turn it off with the G-code. If we look at the same process in grooving, we can do it in the X-axis. We can do it in, like we said earlier, in taper or drilling. But in this case, here's an X-axis. Again, we're making like a corrugated cut. So when that tool comes down, it's not just hitting the surface, the material's coming down on top of the tool. Fantastic technology, LFV, low frequency vibration. And then often, maybe more importantly, as on an ID, always there's chips and big stringers inside that is difficult to get out. And LFV can do chip breaking down inside even the smallest of grooves. We can use an LFV cut on ID grooving. If we try to look closer at, for example, we have 3 different modes. Here's mode 1, which is multiple oscillations per revolution. And you can see the slow motion video that demonstrates it very well. Perfectly formed chips. Second mode is multiple spindle revolutions per oscillation, mode 2. We might use this for turning, but we can also do it for grooving. So this might spin 1 or 2 revs, then oscillate. Here we can program a longer chip. Sometimes the chips are too small and we want to make them longer. A newer mode to LFV is threading. So tough materials threading can make some nasty chips that just don't break. And so we have the ability to oscillate cut in threading. And what happens is the last 2 passes are standard passes, and that's how you clean up the thread. And of course, LFV can be used for drilling. Here's an example using mode 2, multiple revolutions per oscillation. You can see those chips breaking. And this example is using a smaller diameter drill and using mode 1, which is multiple oscillations per revolution. And the interesting part of this little video is the showing of the fine, perfect chip. And so even though this looks like high pressure, this is just regular pressure going through this drill. Look at the perfectly formed chips coming out of that process, LFV. And so many different examples. Here we have just a general, the part you saw earlier, but let's see the whole cut. And so here's the turning that we just saw, the first example, mode 1 LFV. Again, this would be multiple oscillations per revolution. Fully programmable, we can change it as needed. And here we have a perfectly controlled chip, so we have a perfectly controlled process. And there's the turn as it goes. And we can go up an x-axis, over a chamfer, over a radius, any kind of motion we need. In this case, it did 2 passes, a rough and a finish. And if we continue on here, we're going to show a little bit of the OD grooving that we saw earlier. And in this case, mode 2, again, the breakdown of just the perfect photography shot to show the breaking of the chips. With coolant and things, you can never see this, but in grooving, you always have a circular chip that wraps all the way around the part. So here you can see it's breaking the chips just perfectly in an x-axis, X and Z and taper, just anything as we go. And we can turn this off and on at any time with a G-code. And here we go again, LFV. Look at the chips break. That is not a chip breaker from the tool. This is oscillation of the x-axis as it's cutting. Perfectly timed with the spindle. And here we're going to go into a stainless steel part. This part is a long pin. This happens to be what we call an L12 Type 10. It's a newer model, Cincom. And it starts off with some LFV on the subspindle side. And the first roughing pass here, you'll see it does not utilize LFV, and we have a longer, stringier chip. But once we get into the next pass, there's the longer chip. Now you'll see LFV is turned on, and look at the perfectly controlled chips. Look at the length. And we can change the length of that chip to whatever we want through a simple change in the program. So LFV can be on the subspindle side, it can be on the main spindle side, it can be on drilling, it can even be on cross drilling. In this case, these are live tools from the end face. This could utilize LFV. This specific process, I don't think we did, but we definitely can. And as we go into this part, we'll just show some other features of Cincom. Here we have the ability to add a 4-time speeder. Here we have a full Y-axis on the L12 Type 10, so the subspindle can do any kind of Y-axis work. We're actually milling a pocket there. And here's the long turn that we have on the main spindle side. It needs LFV. We're going to show you an example in a minute, but here's the two compared. 303 stainless. Because of the part, we only get one depth of cut. We don't get the rough and finish. It's not possible. So we have to take a very heavy cut, and you can't go 10 thou per rev. So we have to go slower. It's about a 1 thou per rev. And LFV just perfectly breaks the chip. Let's take a look at the chip. On the left side here, we have non-LFV. And again, you have no choice. You have to take the cut, and you have to have a feed rate that gives you the finish you require. And on the right side, fully programmed through LFV, simple to change. Look at the chips on the right side. Our technology for breaking chips from Citizen, LFV, low frequency vibration. And we really want to thank you for joining us today with our exciting cutting technology, LFV. I'm going to put this slide I'm speaking. And if you have any questions on LFV, please contact your local distributor, and you can find your distributor at www.marucit.com, MARUCIT. And if you have questions on LFV that we didn't cover here, I answered a few by typing. But if you have any questions on LFV, you can email me directly at bsuch@mctz.com. We really appreciate you taking the time for joining us today. And we invite you, we have another event on November 10th for our laser L2000 system. We're going to be demonstrating laser cutting and laser welding review on Citizen-Cincom machines, and we can actually do it on Citizen Miano also. So thank you again for joining us today.